Hello, everyone, and welcome. We are doing a little bit of show and tell here at the Topherspin Meteorites Knowledge Bowl and Hangout. Kind of like an impromptu little recording today. I'm going to try to not edit it at all. We have about 5 people doing show and tell. I'm going first. So away we go. All right. So the first item that I want to show off is something that I purchased for myself for my own collection. It is pronounced, I think, Gyarub, Gyarub Zangbo.
Mm.
Has anyone heard of it before?
Yes, very cool.
It looks like that on the outside. Does anyone want to guess what type of meteorite it is? Besides Scott,
Pallasite.
who obviously has one.
Pallasite.
Here we go. This is a Chinese Pallasite. So this is the only other Pallasite I have from China besides Fukang.
Topher, that's a really good one. It isn't coated with epoxy like a lot of them.
Yes, I agree. That I thought there was someone who bought or there was a lot of large thin slices where you got 4 times the epoxy than meteorite floating around, and I really thought that they, in my opinion, ruined the entire stone to get those slices, and then you couldn't even see the meteorite. So yeah, I was super happy, Scott, when I had the opportunity to pick this up.
And that's a really cool one because it's not from the Pallasite main group. So it's a very unusual Pallasite. It's pretty as well as unusual.
Topher, is that a metal blip in the olivine crystal?
We're at
The big,
yeah, right here.
yes.
Yeah, would love to see those.
Hmm.
So here's the it's weird. Scott disagrees with you, but it doesn't agree with the Met Bowl. I believe the Met Bowl shows this as a Pallasite, but you were alluding it to being an ungrouped, and that's what Yang is talking about here. Ungroup with is that Parox?
Pyroxene.
Paroxines? Yeah. So maybe we'll get a clarification on that. But this is a yeah, we're trying to keep it simple. So this is a palace, and we run into main groups and everything. So this is a Pallasite. Yeah, I can't even backtrack now, guys. Sorry. Let's just enjoy the beauty of it rather than the science of
it
it today.
it's an ungrouped Palisade, I believe, which is like 1 of 14, I think. Is that correct, Scott?
Yeah, it's very
Yeah.
small number of them. And what's really cool about Pallasites, it's where the iron part of a planetoid came together with the crust of a planetoid. And so you have both the metal and the sort of pretty gem-like inclusions in it.
Silicates. Yeah.
Thank you. Once again, my crew saves the day. I really appreciate it. So this is one that I bought for myself, and I'm really super happy with it. And then, of course, Yang always has to be overly generous. A belated birthday present. This is some lunar that's being classified. And at first I thought he sent me an important test cut. And then I realized, oh, I need to get my eyes checked. It's an imperfect cut. But I am very interested in what this will be classified in because it looks to me as though it has lots of crystals.
Whoa.
Topher, did that card say 112 grams of total known weight?
Correct.
Wow, he is generous.
I know, 112 grams of total known weight. Let's thank you, baby. We'll bring this back in for a second. 4.3 gram of a very important test cut. 112 grams, and it's being classified by Daniel, which is nice because we know Daniel will really get into those class.
Yeah.
Yeah, that's
pretty.
That's not that imperfect of a cut.
Well,
yeah.
But still, yeah. But it does have some really interesting, nice class in there. So when I looked at it under my eye loop, like for instance, this right here looks troctolitic to me. Wow, that's my tip is bent. Yeah, that looks troctolitic to me. But some of these over here look really, really crystalline. Yeah, super interesting. But learning point, there is no nickel, iron, metal in lunar samples. So when you're looking at this, that is one reason why you're looking at a meteor and you're going, wait, isn't there? Wow, that is really crappy quality. Wow. So if you're ever looking at, if you're looking at this wondering why there's no metal in it, there's no visible flakes of metal because this is a lunar sample, and it does, and lunar sample does not have metal in it except for usually from impactors. So those are my little two show and tells. And Yang, thank you very much. I really super appreciate it. You're overly generous and a great friend. With that, we are going to Marissa. Marissa, what do you have for us today?
Hey Topher, yeah, I'm gonna screen share, and I've got a couple of lunars that I can show.
It's got a
Ooh,
dark
look at all the
matrix.
dark material in that one.
Yeah.
Yeah, so this is NWA 12985. It's classified as a lunar feldspathic breccia.
It's pretty.
Yeah, I love these dark areas that look like it has no brecciation in it, but
Yeah.
then you can see lighter material like dark grays into light grays into white. Looks like it gives it depth.
Mhm.
Now, Marissa, could you do me a favor and explain lunar feldspathic breccia?
Well, a
And we
lunar
have the whole crew backing you up, so don't worry.
So, a lunar feldspathic breccia, it's obviously in the term there's a lot of brecciation in it, and if I'm correct, which the crew can back me up, I'm not an expert in lunars, there's going to be plagiate clays, there's going to be feldspar, and a lot of your breccia pieces are going to be more angular from the impacts that this thing has suffered, and that caused all of this mixing that we see here.
Absolutely.
Anybody else can chime in, obviously.
I like that explanation. We're not having to, we're not feeling obligated to mention every known fact to man. The breccia, as you were describing here, is an assemblage of many other little stones. So that's why we're talking about little clasts. When we talk about clasts, you can think of that as a stone or a pebble embedded inside this lunar slice. So that's when I mentioned class, and I mentioned something being troctolite. You mentioned something being, you know, anorthosite or plagioclase or feldspar. The scientists will look into it, Daniel, whoever did, and looked into it and came up with an analysis of what class make up this breccia of pebbles that came together through impact. And that kind of speaks to what we're looking at here.
And I would like to note this is a small piece. It's only 1 gram.
A lot of beauty in
A
1
lot,
gram.
a lot going on in that, yeah.
And
then
this
the-
stuff is basically, sorry, Marissa, this stuff is basically soil off of the moon that's been compacted into a rock by an impact and then knocked off of the moon. So this is lunar dirt fused together.
Regular.
Topher, did Daniel describe it the way to tell the different, I guess, breccias apart is that we're looking at the class, not really the matrix in between them? That's how you tell the difference between like a fragmental versus a feldspathic?
You put me on the spot like I put Marissa on the spot. I'm gonna.
Oh,
fail.
sorry. Okay.
I'm not gonna pass like Marissa did.
I do remember there being a conversation about that, Sue,
Yeah.
but I even tried to take notes, but it was
hard to follow. Okay, yeah, I'm
No,
getting
there was a
deeper, like I said.
and I should have
Commotion.
asked you in that moment to re-explain it because I really couldn't follow because my kids were distracting me. But You had mentioned that it was maybe going to be one of our quizzes when the Kahoot thing was still a thing. And
Yeah.
I did try to take some notes on it because there really was some interesting facts there, but I unfortunately I missed it and can't back you up now either.
We'll have to wait from the lab.
Yeah, yeah.
Well, first one to post a timestamp to it from my channel wins the absolute prize of our thank you. Marissa,
Ooh.
And this is the last one I wanted to show. It's another tiny little piece, and it's another lunar feldspathic breccia. I really wanted an example of a whole stone lunar so that I could observe the outside. And this is NWA 11474. It's got a little bit of caliche going on. I really wanted to observe what these look like when you essentially pick them up off the desert ground, and maybe you clean it up a little bit. I'm sure it got cleaned up a little bit, but I love that you can see the dark areas versus the brecciated white areas.
it's actually
Yeah, on
like
the
getting
outside.
it's like getting a sneak peek into it.
Yeah, that's really cool.
And caliche, do you want to take a whack at that? Or you want me to go first?
Yeah, you can take a crack at that.
Okay, and then I have the crew backing me up when I screw up. Caliche is a terrestrial contaminate. It is I think a limestone or something like that that attaches to the rock based on moisture. So connection or touching contact with the ground is required. So that's when you see that caliche on a meteorite or an earth rock, you know it's been there for a while. That talks to the length of time that it's been there. Open for anyone else to.
And it's
Bio-
basically like the hard lime deposits on your faucet at home.
And one way to remove them, you wouldn't want to do it to a lunar, but if you had a stony, you can soak it in like a vinegar, and it'll attack that and remove it.
Yep, and I just wanted one just to see again how they look when you pick them up off the ground in the desert. Because most of these have come from Africa, and you know, pieces are still going to be small because these are still very, very rare to find.
Marissa, thank you.
You've got one heck of an eye. Week after week, she shows us stuff, and every single thing she shows us, you know, there's always an option. There's always an option to get this piece or the other piece, but every single piece that Marissa picks is aesthetically pleasing.
Yeah.
Like, you've got one heck of an eye.
She
Thank
does.
you.
And the great thing about that is there is so much beauty in these pieces. If you notice, the scale cube is 1 centimeter by 1 centimeter. So this piece is about 1 centimeter by 1 centimeter. It's probably under 1.5 grams like the other one was. And you're not talking about a huge amount of investment to have an authenticated piece of the moon. And that's what Marissa was alluding to when she says this is an NWA followed by a number. When it's classified by science, it's actually the material is given a number. Northwest Africa of where it came from, followed by a number, depending on its that particular find. So thank you very much, Marissa. I really appreciate that.
Yep.
We now have Scott next on deck. Scott McGregor, how are you, sir? You got some Lonsdale lights to show us?
Hey, no Lonsdale light today. I do have a small lunar that I'll show, and this is NWA 14137, and I'll go to screen share to show some better pictures of this here. It's an interesting one because if I had shown you this rock as part of the meteorite or meteor wrong, everybody would go, that's a meteor wrong. And what's interesting about this is that almost anytime you see vesicles, which are these little sort of holes in the rock there, it's almost always indicative that it's a terrestrial lava or something like that. And you could find 1 billion of these rocks on Earth, and none of them would be lunar except this one. And I'll show you a little bit what it looks like as a slice here. So if you cut into it, it's only 77 grams. It was a single stone find, 77 grams. But what I love about this is a lunar Mare basalt. And what that means is it's from the dark parts you see on the moon. So when you look at the moon, full moon, you see dark parts and light parts. This is the dark part. And they used to call those mares or oceans, which they weren't really. It was just lava flows. And it's a basalt, which means lava. And there's two interesting things about this. One is it's unbrecciated. So Marissa showed you brecciated, which is all kinds of rocks mixed together. This is unbrecciated, so it's a single like lava, single flow of lava, and it didn't get lots of rocks mixed together. The other thing that's really unusual about this is it has vesicles. Vesicles are those little holes, and you can see here the shadow of the light. And it's very unusual. They're caused by gas bubbles. So in lava on Earth, if you see lava on Earth, it has lots of bubbles in it from the gas. Of course, on the moon or other places, they're more round because the gravity is lower, which helps a lot there. But it's very unusual. There are almost no lunar basalts that have vesicles, so very rare. Here's another picture of that there. And one more you can see, here it is. It's not very big, but I really like the vesicles on this.
That is an amazing sample, Scott. Unbelievable. You're exactly right. I mean, looking at the outside, that's not what we expect a meteorite to look like. It's beautiful though, man. Wow. Yeah, and those vesicles are we've been featuring a lot of meteorites with vesicles on the channel lately, and I think before we go to Dave Pinsky, I want to just point out that the most common meteorites to be found here on Earth is what, guys? What type?
Stony.
Ordinary chondrite.
Ordinary chondrite. Yep.
Ordinary stony chondrite, just a rock like you find out in your driveway, but from space. When you talk about the rare stuff like achondrites, like the moon and Mars, or things like that, you are really or pallasites like we showed earlier. Those are the rare of the rare. And when we're showing you samples that have vesicles in it, don't expect that to be in your sample. We're showing you the rare of the rare because we're collectors. We go after those rare oddities. We don't want just a normal, average, ordinary slice. That's not fun enough for Scott. He wants one with vesicles. So we go after those oddities, those rarities, and you shouldn't use that as a touchstone for going out in the field and looking for yours.
Well, Topher, I would say even stronger than that. If it has vesicles in it, it's almost certainly not a meteorite. And there are very, very few exceptions to that. Unless you've got a scientist who's done oxygen isotopes on it, it's not a meteorite.
Agree. But that's what makes that such a stellar piece, Scott.
Wow,
And I want
I'm
to
gonna
clarify,
have
Scott doesn't just go for the oddities, he goes for historically significant, scientifically significant, and aesthetically pleasing and fun.
Well, thank you, everyone. Appreciate your feedback on that. I think I promised Dave next, didn't I? Don't want to let the crowd down.
Yes, you did. I'm going to go back to a lunar feldspathic breccia. I have, here's, okay. Can everybody see?
Yep.
Yes.
Okay, so this is a NWA 11273. It's about 7.36 grams. You can see I do have a cube there to show the size. And one little aspect of this, it was beautifully described what a breccia is, but think back to when you've looked at the moon. And if you've looked through a telescope or with binoculars, you see an endless amount of craters, more so on the highlands, which are the bright areas, and less so on the Mare, which is younger material. This one comes from the highlands. So again, it's going to be mostly breccia. And when you look at all those craters and then look at this, you're really seeing the results of all of those meteorite impacts on the moon. There's no atmosphere on the moon to stop these things. So every little bit of extraterrestrial or extra lunar material will hit the moon. The same thing happened with Earth, but we were lucky because we have an atmosphere that burns some of them up, but it has been hit a lot of times. But plate tectonics and water and air have gotten rid of that, and so you can't find a lot of the breccia on the Earth. But on the moon, it's all over the place. And when you look at this meteorite and look at all of these clasts, it tells a story of particular events and many events. And imagine the amount of energy it took to smash these things together to make this area this dark. Those are shock areas that are dark. And these are the areas that are, I believe they're anorthosite. So correct me if I'm wrong.
Yeah.
But
You got it.
yeah, and so anorthosite is some of the oldest material on the moon, and the impact just blasted all that out, shocked some of the material into darker rock, and then got solidified into this material. Like you said, it was basically dirt, and the pressure eventually made it into a hard material, and eventually this got knocked again. And then blasted out of the escape velocity of the Earth, and then eventually landed on the Earth. And we have this. So I tried to put this a little less scientific and a little bit more into a story of how this got to be. And just look at the moon through binoculars. I always advise people to do that. And the more you look, the more you'll see.
Yeah. Very well said. I like to think of meteorites having, three ages. The material from creation to ejection, where we created in the solar system, and so like one age of the material would be from its creation to ejection. Another segment of its life period would be the free floating in space until it's landing on Earth. Then the third cycle would be its terrestrial life on Earth until it's collected. So there's three different ages the way I look at meteorites. And one thing about lunar, like we said, it doesn't have high metal or any metal. So it's going to erode and weather and dissolve and be forgotten about here on Earth a lot quicker than an iron or a pallasite or anything that has a lot more metal. Thank you very much. Our last and final participant of the day on MetCam 2.9. He needs to get 3.0 because this one's faulty.
Yeah, so Topher mentioned ordinary chondrites.
Okay.
And this is one of those ordinary chondrites, but it's kind of a special one. So this is hopefully a very primitive type 3 ordinary chondrite that still shows the chondrules as they were formed. That's a very unaltered, very original as it started. This is what all of our planets are made out of, is this stuff.
Very colorful.
Yeah. This is remarkable. And one of the things about these chondrules, these are the little bits of silica, little round balls that make up chondrules that go into chondrites. And those chondrites are called the stonies, the ordinary. So those are the ones that we're talking about seeing most often here on Earth.
Right. That's the most common class of meteorites, roughly 85% of meteorites. And this one is special because it hasn't changed very much since it formed 4.5 billion years ago.
Thank you very much. And that's a focus for your collecting, is going after those unaltered ones where I will stay with the differentiated planetesimals. That's my give me an ungrouped A chondrite any day. And if you don't know what that means, search for it on my channel right now. I guarantee you there's a video about it. Thanks a lot, everyone. Have a great night.